Hello friends, Mr. Cockburner coming back at you. Tonight we are going to be working on linear inequalities, testing, graphing, and writing. So let's not waste any time and let's get a rocking and a rolling. So the very first thing is, if you recall what an inequality sign is, we have the gator mouth opening to the left or to the right. If you see, I just want to draw your attention to this top part is grouped this way. Greater than, so if it's pointing to the right, that arrow again, if we just draw a little arrow here, you can see how it points to the right, is going to be shading above the line, all right? And then if you look going horizontally again, we're going to be shading below the line. Again, this writes the word less, so it kind of helps us out with that. And then if we look vertically, these are solid lines. So if we write more by putting that equals underneath, we have a solid line when we graph. If we write less, we're going to color less or write less, and that's going to look like a dashed line. We're going to get into that here in a second. Let's rock and roll. The very first thing, that dashed line you can see in this problem right here, and it's dashed because if we pay attention to that logo right there, it does not have that equal sign. So this is our dashed line here. And if you see, that says greater than, so it's shaded above, all right? So it's like pretend like you're going up this mountain here. If we're climbing up the mountain, the clouds are always above your head. So greater than is going to be above. And then if you're walking up the mountain and it's less than, like this one over here, you shade below. So you're walking below or on top of the mountain. So you shade below, all right? So again, if you notice the difference between these two slides, one's pointing right, one's pointing left. Greater than on this side, and then less than is on this side. So you can see how the shade is less than the line, and then this is above or greater than. Again, these top two are dashed because you don't have that extra line underneath the inequality. And now if we look at the bottom, this is above because, again, it's greater than because we're going to pay attention to that sign. And then we solid line because it tells us that it's equal. Meaning a point can be on this line and still be true, where a point cannot be on the dashed line. It would not make it true. And then last but not least, we are going to be less than here because we are shading below the mountain here. And then equal to means that this is a solid line, not a dashed line. All right, so let's see what this looks like moving forward. Great question here is, which ordered pair is a solution to the system? So what we're looking is, this is our solution set, this whole shaded area. And what this also is telling me is that it can't be on this line, that linear function, because it's dashed. So if it's on the line, no bueno. If it's in the shaded area, awesome. All right, so let's try. Let's see, look at A, -3, 0. So if we go at the origin, jump left 3, and plot right there, is that in the shade? No. So let's cross that one off the list. Now let's go with B. Start at the origin, 1, 2, 3 hops to the right, and then up 2. Ooh, that looks pretty good right now. So let's keep that one around. C says 2, 1, so 1, 2, and then up 1. Uh-oh, that's on the line. Is it allowed to be on the line? No, because this is a dashed line, so we're going to get rid of that one. And then -3, holy smokes, where are we going? Yep. And then up 2 is right here. So the only point that makes sense, winner, winner, chicken dinner, just like the Browns, 3 and 1. Right now, we're looking at 3, 2 as our answer. So go right 3 and up 2, and there's our answer in the shade. Tell whether the ordered pair is a solution in inequality. So real simple. All we're going to do is, this is my x value. This is my y value. So wherever I see y, I'm going to plug in -3. Wherever I see x, I'm going to plug in 5. So the very first thing I come across in this inequality statement is a y. What does y really equal? -3, because I'm just going to take this and substitute it in. And then I don't mess with that inequality sign. Negative I don't mess with, because here's my x now, which is 5. So I substitute that in. And then +2 I don't mess with. So now we're going to say -3 on the left, clean up those parentheses. We have to distribute to this -5, or this 5, sorry, making it -5. plus 2. Now let's simplify that right side. What's negative 5 plus 2? Negative 3 is less than or equal to negative 3. Because this equal to is there, this is indeed a solution. So that would be in the solution set, because negative 3 does in fact equal negative 3, because remember there's two cases here. It's either less than or equal to that number. All right, so this is a solution. Now what we're going to do is focus our attention on graphing. So the very first thing, I put these steps here on the bottom right to help us out, make it move a little bit quicker. Is y alone? Yes or no? Does it say y and then your inequality sign? Yes, it does. Rate of change, is it positive, negative, 0, or undefined? We are going to look at that coefficient, negative 2. So this is going to be going downhill. All right, our slope is negative 2 because that's the bestie with x, remember? And then our y-intercept is at positive 5. We can tell a lot from that slope-intercept form. Do we connect the dots? You got to look at the sign, ace of base. I saw the sign, and it opened up my eyes. I saw the sign. You guys don't remember that one? All right, look it up. Ace of Base, 1994-ish, maybe. All right, great song. Your parents know it. They probably loved it too. Connect the dots. Solid or dash? Remember, solid is going to have the equal sign underneath it. Dash does not. So if we look here, that's our sign. Going to be solid because it has that equal sign underneath. Do we shade above or below? If you need it, go back to this chart way up front. And all we have to do is pay attention to what our sign is, which is this one, I believe, right here, which means shade above. All right, so we can use that information. If you need to go back to that, you can. And yes, that means above. So now what do we do? We always start with our y-intercept of positive 5. We set our reminder as our slope is going downhill, down 2, 1, 2, and right 1. And I'm just going to keep plotting until I can't plot no more. I'm just going to keep going down 2, right 1, down 2, right 1. And now I can't go from the original point and go up to left 1. However, I need to now remember that I'm going solid, and I'm going to shade above. So I'm going to connect these dots as straight as I can with a solid line. And now remember, I like to draw a little guy mountain climbing, just so I remember what's above and what's below. The clouds are always going to be above his head, and the mountain's going to be below his feet. So this says above, so I'm going to shade this area above. All right, and again, remember, this can be on the line because it's solid and it's equal to. So this is my solution set, which is all that shaded region, including that linear function. All right, moving on. Y is greater than 2/3 x minus 2. So the reason why I picked this one is because you have this fraction, that F word right there, that you guys are afraid of sometimes. I don't want to be afraid of a fraction. That's called fractophobia. Look it up too. That's a fear of fractions. No need to be scared of those. That's actually going to help me when I do my rate of change here. So is y alone? Does it say y, then the sign? Yes. Rate of change, is that positive, negative, 0, or undefined? That's what we have in blue there. That's 2/3, so that's a positive slope, so it's going to be going uphill. What is that rate of change? It's 2/3. What was my B? I did in green, was -2, so that's where I'm going to start, right? My graph is below the x-axis. And then do I connect the dots on this one? No, because it's a dashed line. How do I know it's a dashed line? Because this is my inequality sign. Now, do I shade above or below? Greater than means shade above. So let's get to plotting. Where do I start? My starting point is always that B. So -2 on the y-axis. And now from there, I'm going to use my slope, which is 2/3, which means go from that starting point, not the origin now, go up 2 and right 3. From that point, go up 2 and right 3. And now I see that I can't graph anymore to the right, so now I'm going to shift my attention to the left part of the graph. And I'm going to go back to my starting point right here at -2 on the y-axis and do the opposite. Instead of going up 2, I'm going to go down 2. And instead of going right 2, I'm going to go right 3. I'm going to go left 3. So from down 2, left 3, because that means -2, -3, which equals that, right? I'm going to do that one more time. Down 2 and left 3. And now you can see that that's that constant rate of change. My dashed line, so I'm going to connect these with a dashed line as well as I can with this pen. I don't know what it's going to look like. All right, you can't really see that, so I'm just going to try to make it as straight as possible. That is a dashed line, and then we're shading above. So remember, that little mountain climber always walks on the mountain, which is below your feet. So we're going to shade above into the sky, which is always above us, unless we fall, which would be bad. And what does that dashed line tell us? That these points that we plotted will actually not be solutions because it's not equal to the line. It has to be in the shaded area. One trick they always tell us to do is try a test point. So the greatest test point to do is 0, 0, because it's pretty easy to add, subtract, multiply, and you can't divide by 0. So we can only do 3 of those operations that we know and love since kindergarten. So if we plugged in 0 here, because we're just going to make zeros our x's and y's, and test that solution out. 2/3 times 0 is 0. Minus 2, we get -2. Is 0 greater than -2? Of course it is, right? Because you can see -2 here is on the x-axis, and to the right is greater than. So we're good to go. This one I put on here because, if you notice, the first question has been yes all the time. This one is a no. So we're going to have to go back to what we were taught back at the beginning of the year. 2x, or 10x, sorry, minus 3y is less than or equal to -15. We want it to say y and then the sign, so we need to get y by itself. So I'm going to subtract 10x from both sides to move it from the left to the right. Now I get -3y. Don't forget that negative. All right, less than or equal to -10x minus 15. We are way too far along to make the mistake of combining those. Why don't we combine those? Good. One's an x term, one is a constant. We don't combine x's with constants. So now, here's the tricky part. We are going to divide by a negative. If you recall from way back when, that first week of school, it's been a while, we had, when we did inequalities, whenever you divide by a negative, we have to flip our sign. So right now, that sign's pointing left. I'm going to make it point right, because if you notice, this was a negative. I'm going to change that to a positive, because -3 divided by -3 is 1. If you look here, this sign's going to change because -10 divided by -3 is positive 10 over 3, x. And then again, this sign's going to change too, because a negative and negative make a positive. What is 15 divided by 3? Is 5. So now is y by itself? Yes, it is. Is this slope positive or negative? We're going to look at x's bestie right there. 10 divided by 3, that's a positive fraction. What is that rate of change? That rate of change or slope is 10 over 3, which is going to be a little bit difficult to graph. And then our b is going to be positive 5. Are we going to connect dots? Again, that is all about the sign, and we kind of flipped the sign, so be careful with this one. Here's our sign. I rewrite it. Is that solid or dashed? Does it have a reminder that it's solid? Yep, right there. That's what it's going to look like. That's a solid line underneath. That's how I always remember it. And then are we going to shade above or below? Because it's pointing to the right, that is going to be shading above. All right, so let's get started. We're going to start at positive 5. And then from there, it says up 10 and right 3. So we can't go up 10 because it only goes up to 6. So let's go down. I'm just going to show you here. Down 10 And then instead of going right 3, we're going to go left 3. Because again, that is equivalent fractions of 10/3 and negative 10 divided by negative 3. All right, so let's go down 10, because remember, it's the change of y over the change of x. So that top number means to go negative 10 down. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then left 3, which is 1, 2, 3. We plot right here. And again, remember, we're starting at the y-intercept as our original point. So we're going to go down 10 and left 3 because we have a positive slope. That's why I like to do this too. And now we're going to have a solid line, and I'm going to try to make this as straight as possible without a straight edge. There's my line. Again, we're going to shade above, and that's going to be this here. And the reason why we need to pay attention closely to this solid part is because those points that we actually plotted are solutions because it's set equal to that inequality. All right? Here's a weird one. Why do I say it's weird? It's because we're missing the y value. All right? So when we go to answer this question, is y alone? What do we say? What do we say? There is none. So what does that mean? It's a special case. What does that special case mean? It's either going to be a horizontal line with no slope, or it's going to be a vertical line as an undefined slope. Remember, we want y. If there's no y, it's the weird one. It's the one that's not a function, right? So this one's no fun because it's not a function, which means the way we test functions is with vertical lines. So we know the only line that's not a function is a vertical line. So where's x4? Right here. So what this means is that we're going to get an undefined line or undefined rate of change, and then we don't have a b. So this is kind of odd, but you know what? We can do it. Is this solid or dashed? If we look here, remember, it doesn't give us that reminder, so this is going to be dashed. All right, if it gave us the reminder, it'd have a straight line right there. Now, do we color above or below? This is kind of weird because when we go to do this undefined line, it's going to be dashed vertically. And now we have to look at the x-axis, that number line. Because it's greater than, it means shade the greater side, which means these numbers get bigger. Just do your test point. 3 is smaller than 4, so that's less than. 5 is greater than 4, so we know that we're going to shade to the right. And again, what does this dotted line mean? It means that those points cannot be part of the line to make this true. All right. Another thing we could do, again, that we did that one example is test 0, 0. Since we don't have a y, we just put 0 in for x. Is 0 greater than 4? No. So we know that this is not a solution, or the left side of that vertical line won't be a solution. All right, another weird one. We're missing our x term, which is no big deal because we're still going to get a function here. What is weird is the fact that it's 0. So is y alone? Yes. What's my rate of change? Positive, negative, 0, undefined. 0 slope. What's a 0 slope look like? We have 0 here. It's a 0 slope. Our b is actually the number 0. Is this connected or dashed? Again, I'm going to rewrite it. It's all about the sign, right? You know I'm all about that sign. Okay, I'll stop. Solid or dashed? It does not have the reminder, so it's going to be dashed. Is that going to be above or below? Y is less than 0. What do you think less than means? Good, it has that L right there to spell the word less. So when we do that, this is actually going to be on the x-axis, which is kind of cool. It's kind of hidden there. However, now we have to color, which is my favorite part of this lesson, is we're going to color below. Well, what's above, what's below? That's kind of makes sense, right? Shade below. Oh, and you know what? I just realized I didn't do my dashed line. I did a solid line. So me, with my eraser, I can easily take it and fix my mistake and have my dash line. All right? Any questions there? I tried to pick the wild ones, so we saw the x by itself and the y by itself only. So now let's go backwards. So now we're going to write the inequality. So for the majority of these problems, it's always going to be y, the sign, the rate of change, the x, and the b. So this is the m, this is the b, and we don't know what the sign is until we look at our graph, all right? So let's look. What's the rate of change? Is it positive, negative, zero, undefined? That's going uphill, right? So let's draw that mountain climber going up the hill. I like to try to pick that y-intercept because it's going to give me my answer here of -3. And I'm going to look for a point where it crosses these crosshairs pretty nicely here. So I'm just going to plot those points that are easily plottable. And we're going to go from the y-intercept up, because it is positive. We go up 2 and write 1, giving us our rate of change or slope as 2. Are the dots connected? Yes, so we know it's going to be an equal sign. Now, are we shading above? Are we shading the clouds, or are we shading the mountain? As we go up the mountain, we're shading the mountain. Where should the mountain be? Below our feet. So that's going to be below is that L, or the inequality sign pointing left. We connected the dots, so that's solid. Are we shading above or below? If we're talking less than, we are talking below. So now we know our sign looks exactly like that. So I can build this here. There's my sign. I already have my slope there. And I have my y-intercept of -3. If you hear any crackling, that's my wife making lunches, maybe. Hey, what are you doing over there? Making lunches for the kids. Cool. That means I don't have to do it. All right. Here's a weird one. Why is it a weird one? Because we have a vertical line. That vertical line means x, right? Because this is not a function, and every other function starts with the letter y, which is x's best friend as far as the order pair goes. So now this is shaded to the left. If we say to the left, that means below. So we're going to have the left sign show up there. Is this solid or dashed? It's solid, so we're going to have that reminder underneath. And then what's my value? My value is -5. All right, so I can use this stuff, but I'm getting pretty good at this now where I don't think I need to use the cheat. But if you need to use the cheat, by all means, write that down and you'll be good to go. Write the inequality to represent each graph. So we know we're going to have a y, we know we're going to have our x, and now we need to complete the sign, the rate of change, and the y-intercept. So if we look here, I'm going to draw my mountain climber. If you look, as they're going down the hill, what's shaded above or below? Above. Is this solid or dashed? Dash, what does that mean? Above means greater than. Dash means we don't get the reminder, so now I have my sign. Now again, I kind of like doing the y-intercept first, which is +1, because it's touching the y-axis at 1. And now it looks like we're going down 1, right 1, down 1, right 1, down 1, right 1. So that's just a factor of 1. But remember, we're going downhill, so it's -1. Oh no, my battery's running low. I gotta hurry. -x. Because it's -1. I'm going to be intelligently lazy and not put that 1 there. And then we have our +1 here. All right. I'm going to kick it in a higher gear. Here's a weird one. Why? Because it's not a line that's on a diagonal, right? It's a horizontal. That means y by itself. Is this solid or dashed? It's dashed, so we know it's going to be without the reminder. Is that shaded above or below? Again, if we're walking on this line, it's shaded above, right? So that's going to be above, meaning greater than. Dashed. And then what is my b? My b is -4. You can see right here, -4. And then this is a 0 slope. So we don't have a slope because 0 times x is going to be 0. So again, we're intelligently lazy and don't write the x term. And now we have that. Clark is having a party at his house. His father has allowed him to spend $20 on a snack food. He'd like to buy chips that cost $4 a bag and pretzels that cost $2. Write an inequality. So I always like to star my information, which is normally my numbers. Since this is math class, we pay attention to our numbers. So 20 is my total. If you have 20 bucks, you can't spend more than 20 bucks because you only have 20 bucks. So we know that this left side, where my chips and my pretzels are going to be, has to be less than 20 bucks. Could it be 20 bucks? Sure. We can spend $20 on the nose, so we're going to put that equal sign. And now we need X's and we need Y's. I'm going to just call potato chips X, and I'm going to call pretzels Y. So how much does a bag of chips cost? 4 times how many bags I buy. We don't know yet. Plus 2Y, because 2 bucks a bag for pretzels. And now we have to graph our solutions. And then it says give 2 possible solutions. All right, so if we look here, we can graph by intercepts. What I like to do for that is just make y 0 here. And we're going to get, if we make y 0, I'm going to divide this by 4. And I'm going to get x is less than or equal to 5. So that means on the x-axis, go right 5. 1, 2, 3, 4, 5. Don't go up or down, because we have 1, 2, 3, 4, 5. Got it? And then if I just do the cover up here and graph my y-intercept, I can buy 10 bags of pretzels. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm at the tippy top here. And now I want to connect this with a solid line. Do my best. What does this point mean? It means I could buy, let me just put my answer here, 10. I made 0x, or x0. So that's my y-intercept. And this is my x-intercept. What does that mean? I could buy 5 bags of chips and no pretzels, right? So this is my chippies and my pretzels instead of X and Y. Sure, we can call them that too. And then here I'm not buying any chips. I am buying 10 dry bags of pretzels, all right? And then it says give 2 possibilities. This is less than, so it's got to be below the line. So again, if we draw our mountain climber, the mountain's always below his feet. So anything that's in or on that line is going to be a solution set. My favorite question is right here. If I graph this point, is that a solution? Is 0, 0 a solution? Yes, that means you stole your dad's 20 bucks and didn't buy any chips, didn't buy any pretzels. So hopefully you don't do that, because your guests for the party are going to want to have something to munch on. So anything in this shaded area is any type of combo that you can have. You want 3 bags of chips and no pretzels? Sure. Right? I'm sorry, that's 3 pretzels and no chips. This over here would be 3 chips and 1. It's late. I'm sorry. Yeah, 3 chips and 1 bag of pretzels. All right. Systems of linear inequalities. Remember, anytime we say the word system, it means more than one line. So all we're going to do is graph 2 lines, and then watch what's going to happen here. I'm going to graph this line first. Y solve for. Here's my rate of change. Is my bestie for x. And then my constant is my y-intercept, where my starting point is. I go up to 2. And now my my slope, my rate of change says up 1, right 2, up 1, right 2. Can't go from there. So I'm going to go back to my starting point, go down 1 and left 2. Because remember, down 1 and left 2 still gets you a positive 1/2 slope. I'm going to look at my sign, solid or dashed. It has my reminder to be solid. So I'm going to connect the dots as best as I can without a straight edge. And now what does this mean? That means less than, because you can see the letter L right here. So I'm going to shade this direction. So now in blue, I'm going to graph this inequality. I'm going to start here at -3, plot my point. What do my directions tell me from there? -2, what does -2 mean? Easy, -2/1. So down 2, and right 1. I can't do that anymore, so I went down and right. So now I'm going to do the opposite. I'm going to go up and I'm going to go left. Go up 2, start at that first point, go up 2, left 1, up 2, left 1. There's the point of intersection. Up 2, left 1, up 2, left 1. That point of intersection is not that important because these are inequalities. Why am I dashing this line? Because my sign tells me to. And again, this makes an L, so that means go less than. I always draw that mountain person on the mountain. Less than means the mountain's always going to be below your feet. So we're going to shade this region over here. And I know it's kind of difficult to see. However, this is the blue only. This is the black only solution. Here's neither solution. And then our answer for our problem here is going to be this area right there. The double shade is what we're looking for. And again, because this is dashed, the blue is dashed, it can't be on that line, but it can be on the black line because we do have that equal sign over there. So our solution set is this green double shaded area, now triple shaded area. And now I just want to show you, I'm going to make this one, just for our sake, let's make this a solid line, just so we get both type of lines in here. All right, so how do we do this? I'm going to do this inequality first because it's a special inequality. That's just going to be the y with no slope. My y-intercept is -2. And then I had this shaded so it's solid now. And then if I put a person on that line, is that shaded above or below above his head or below his feet? Above his head, so we know it's going to be greater than. All right, so that's this line right here. Now, in green, I'm going to do this line right here. Again, I'm going to have a y, I'm going to have an x because it's a diagonal line. And now let's look at this here. Where's my y-intercept? It looks like +2, so I'm going to build from the back. I need my slope, so I'm going to look for a point. This point looks pretty good to plot. So I'm going to go down 1, 2, 3, 4. So down 4 means -4, and then over 1, which means -4. And then if I draw that person on the line, this is a pretty steep slope. That's why it's so big, that number -4. Is that shaded above his head or below his feet? That's below his feet. So it's going to be the L for less than. And then it has a dashed line, so we don't have that equal sign. All right. So our system of linear inequalities, if we're writing those inequalities, is y is less than -4x plus 2. And then this horizontal line is y is greater than or equal to -2. All right. So again, anytime we have the word system, it just means that we have more than one function that we're going to be graphing. All right. Again, you know what I say. If you need help, email. Please contact us. We are more than willing to help you out. If we went too fast, pause it, rewind it. All right. But if you have questions, please get them answered. Last slide.